Let us find the 0 of p of x equal to 3x plus 4. To find the zeros of any polynomial, we need to equate p of x to 0. So p of x is 3x plus 4, which is equated to 0. Now transfer this 4 to RHS. It is 3x equal to minus 4. Then x equal to minus 4 by 3. Therefore, x equal to minus 1 by 3, minus 4 by 3 is a 0 of given polynomial p of x. Graphs of quadratic polynomials. Let p of x equal to ax square plus bx plus c be any quadratic polynomial. Then the graph of p of x is an upward parabola if a is greater than 0, and the graph of p of x is an inverted parabola or downward parabola if a less than 0. Here you can see different types of a quadratic polynomial. You can see in all the cases we can observe a is greater than 0. The nature of the graph is always an upward parabola, and here the graph meets x-axis at two decision points. That's why the graph has two zeros. Again, since the line or curve intersects x-axis at a one particular point, that's why the given graph has 1 0. Again, here we have a graph that neither touches nor cuts the x-axis. That's why number of zeros of a given polynomial is 0. So that is, there is no 0 at all. Again, you can see all these are inverted or downward parabolas where a is less than 0. Again, we can see we have two decision zeros, we have a single 0, and again we have no zeros at all. Find the number of zeros of the following graphs. Here we have a graph that intersects x-axis at one particular point. That's why number of zeros is 1. Again, the graph meets x-axis at a two decision points. Therefore, number of zeros is 2. Again, the graph which intersects x-axis at three decision points. That's why number of zeros is 3. We have a line that intersects x-axis at a one particular point, so number of zeros is 1. We have a graph that touches x-axis at one particular point. That's why number of zeros is 1. Again, we have a graph that intersects x-axis at a four distant points. Therefore, number of zeros is 4. Guess the polynomial from the following graph. Here we have minus 1 as a 0, that it means x equal to minus 1. Then p of x equal to x plus 1, that is our required polynomial. Again, you can see 0 as 2, that implies x equal to 2. Therefore, required polynomial p of x equal to x minus 2. Here we have a problem from exercise number 2.1. Find number of zeros of p of x in each case. First one, here you can see a line which is drawn parallel to x-axis that never cuts or even touches x-axis. Therefore, the graph has no zeros. So number of zeros is 0. We have a graph which meets x-axis at one particular point. So number of zeros is 1. We have a graph that intersects x-axis at three decision points. So number of zeros of the following graph is 3. Here we have a graph that intersects x-axis at two decision points. So number of zeros is 2. Similarly, number of zeros 4. Again, we have a graph. Here the graph cuts, and here the graph touches x-axis. So totally the points where the graph meets x-axis is 3. So therefore it has 3 zeros. Next one, form of a quadratic polynomial in terms of alpha and beta. Let alpha comma beta are the zeros of a quadratic polynomial p of x. Then x minus alpha and x minus beta are going to be the factors of given p of x. Then p of x is simply the product of x minus alpha into x minus beta. That implies k into x minus beta minus alpha into x minus beta. So k into x square minus beta x minus alpha x plus alpha beta. So you can write it as x square minus beta plus alpha into x plus alpha beta. Therefore, the form of p of x is k into x square minus alpha plus beta into x plus alpha beta if alpha plus beta indicates the sum of zeros and alpha beta represents product of zeros. Find the zeros of the quadratic polynomial x square plus 7x plus 10 and hence verify the relationship between zeros and quotients. Given p of x equal to x square plus 7x plus 10. So to find the zeros of any polynomial, p of x is simply equal to 0. That implies x square plus 7x plus 10 equal to 0. So a is 1, b is 7 and c is 10. So we need to multiply a and c, that is 1 into 10, 10, and we need to write down the factors of 10 such that the sum of those two factors must be equal to the value of b. So we have 1 into 10 and 2 into 5. We have 2 plus 5 as 7. So we can rewrite x square plus 7x as 2x plus 5x plus 10 equal to 0. Here x is common from both the terms, x into x plus 2, and since the smallest of these two numbers is 5 and 10 is a multiple of 5, that is we can take 5 as common. So 5 into x plus 2 equal to 0. We have x plus 2 into x plus 5 equal to 0. That is either x plus 2 equal to 0 or else x plus 5 equal to 0. So x equal to minus 2 and x equal to minus 5. Thus we have two zeros, alpha equal to minus 2 and beta equal to minus 5. Now let us find the values of alpha plus beta, that is sum of zeros, which is minus 2 plus minus 5, that is minus 2 minus 5, which is equivalent to minus 1. That can be expressed as minus 7 by 1, which is equivalent to minus p by 8. Similarly, product of zeros alpha into beta, which is equal to minus 2 into minus 5, that is 10. That can be expressed as 10 by 1, which gives us the value of c by a. Find the zeros of x square minus 3 and verify the relation between zeros and quotients. Given p of x equal to x square minus 3, to find zeros, first we need to equate p of x to 0. That implies x square minus 3 is 0. Compare it with the a square minus b square, that is we can express x square minus 3 in terms of x square minus root 3 whole square equal to 0. So we can rewrite it as x plus root 3 into x minus root 3 equal to 0. That implies either x plus root 3 equal to 0 or else x minus root 3 equal to 0. That implies x equal to either minus root 3 or x equal to root 3. So thus we have two zeros, that is alpha equal to minus root 3 and beta equal to root 3. Now let us find the values of sum of zeros, which is minus root 3 plus root 3, that is 0. So we can write it as 0 by 1, that is minus b by a, and alpha beta, which is minus root 3 into root 3, that is minus 3, which is equivalent to minus 3 by 1, which gives the value of c by a. Find a quadratic polynomial whose sum and product of zeros respectively are minus 3 comma 2. Given sum of zeros alpha plus beta equal to minus 3 and alpha beta equal to 2, we have form of a polynomial b of x equal to k into x square minus alpha plus beta into x plus alpha beta, that is k into x square minus, we have alpha plus beta itself minus 3 into x plus we have alpha beta itself 2, that implies k into x square minus of minus 3x, that is plus 3x plus 2 to k equal to 1, that implies p of x equal to 1 into x square plus 3x plus 2. Therefore, required polynomial p of x equal to x square plus 3x plus 2. If you like this content, please like, share and subscribe to our channel.